All right, let's talk about congruent segments. So congruent segments are the same length. There's a couple different ways that we can say that. For example, measure of AB is equal to measure of AD. That means they're the same length. Another way that we can say that two segments, line segments, are the same length is by saying line segment AB is congruent to this symbol right here. You read that as is congruent to. So line segment AB is congruent to line segment AD, and that means they're the same length. It doesn't mean they're connected. It doesn't mean they're going in the same direction. It doesn't mean that they are in the same plane. It means they're the same length. Another way to show that two line segments are the same length is with hash marks. So if you have a line segment with one hash mark, line segment with one hash mark, these two are congruent. And that lets us, in a geometric figure, show where the congruent segments are. In this case, these are collinear segments. They're actually on the same line. And this point in the middle is exactly halfway from either end. And that makes it a midpoint. The congruence proves to us that it is a midpoint. Now, a line segment like this could be divided into two equal parts by more than just a point. It could also be divided by a line or a ray or another segment. And if it intersects through that midpoint, so that you have two congruent segments on either side, then we would call whatever that thing might be a segment bisector. Bi means two, and sector means parts. And when we say bisector, it means equal parts. So here's a problem you're going to try next, where you are given that U is the midpoint of segment TV, and your job is to figure out what is the length of TU and TV. We've done a similar thing in a previous example, so I'm going to let you guys try this one out on your own. Use your algebra skills. Good luck.